The sun is more than just a glowing orb in the sky. It's the engine that drives life on Earth and the entire solar system. This blazing sphere of plasma is a powerhouse of energy, an awe-inspiring giant that has mesmerized humanity for millennia. Let's embark on a journey to explore the sun, its colossal size, immense power, and the fascinating phenomena it creates. The sun is a staggering 864,000 miles in diameter. To put that into perspective, you could line up 109 Earths across the sun's face, and it would still dwarf them all. The sun is essentially a gigantic nuclear reactor. At its core, temperatures reach a mind-melting 15 million degrees Celsius. Here, hydrogen atoms are fused into helium through nuclear fusion, a process that releases an unfathomable amount of energy. Every second, the sun converts about 600 million tons of hydrogen into helium, releasing energy equivalent to billions of nuclear bombs detonating simultaneously. This energy takes tens of thousands of years to travel from the sun's core to its surface, but once it escapes, it reaches Earth in just over 8 minutes. This energy is the foundation of life on Earth, fueling everything from photosynthesis in plants to the weather patterns that shape our world. The sun isn't just a uniform ball of fire, it's composed of several distinct layers, each with unique characteristics. The core, this is where the magic happens. Temperatures and pressures here are so high that nuclear fusion occurs, generating all of the sun's energy. The radiative zone. Surrounding the core, this layer slowly transfers energy outward through radiation. It can take hundreds of thousands of years for energy to move through this dense layer. The convective zone. In this outer layer, energy is transported by convection. Hot plasma rises, cools, and sinks back down, creating a churning effect. The photosphere. This is the sun's visible surface, the part we see from Earth. It's cooler than the core, with temperatures of about 5,500 degrees Celsius. The chromosphere and corona. These outermost layers are responsible for the sun's atmosphere and its stunning solar flares and prominences. The corona, which extends millions of kilometers into space, is surprisingly hotter than the surface, reaching temperatures of 1 to 3 million degrees Celsius. One of the most fascinating aspects of the sun is its magnetic field. This invisible force governs much of the sun's behavior, including the creation of sunspots, solar flares, and coronal mass ejections. Sunspots are dark spots on the sun's surface, are cooler areas caused by intense magnetic activity. They can be larger than Earth and often occur in pairs or groups. Solar flares are sudden bursts of energy caused by the tangling and snapping of magnetic field lines. Solar flares release a tremendous amount of energy, equivalent to millions of nuclear bombs exploding simultaneously. Coronal mass ejections, CMEs, are massive eruptions of plasma and magnetic field from the sun's corona. When directed toward Earth, CMEs can disrupt satellites, power grids, and even cause spectacular auroras. The sun is about 4.6 billion years old, and it's roughly halfway through its life cycle. It formed from a collapsing cloud of gas and dust, and ever since, it has been burning through its hydrogen fuel at a steady rate. In another 5 billion years, the sun will exhaust its hydrogen supply and begin fusing helium. This will cause it to expand into a red giant, engulfing the inner planets, including Earth. Eventually, it will shed its outer layers, leaving behind a dense core called a white dwarf, a faint remnant of its former glory. Without the sun, life as we know it would be impossible. Its energy drives the water cycle, weather patterns, and the growth of plants, which in turn support all other life forms. But the sun's influence isn't always gentle. It can also unleash powerful geomagnetic storms that affect our technology. For example, the Carrington event of 1859 was a massive solar storm that caused widespread disruptions to telegraph systems. If a similar event occurred today, it could potentially disrupt power grids, satellites, and communication systems worldwide. Throughout history, the sun has been a source of inspiration, worship, and wonder. Ancient civilizations, such as the Egyptians, Aztecs, and Hindus, revered the sun as a god. In modern times, the sun remains a symbol of power, life, and renewal. It has inspired countless works of art, literature, and science. Despite centuries of study, the sun continues to surprise us. Missions like NASA's Parker Solar Probe are helping us understand its mysteries, such as why the corona is so much hotter than the surface and how solar winds are accelerated. These insights not only deepen our knowledge of the sun, but also improve our ability to predict space weather, which is vital for protecting our technology and astronauts in space. When we gaze at the sun, we're not just looking at a star, we're witnessing the engine that sustains life on Earth. It's a reminder of how interconnected we are with the cosmos. The sun's immense size, incredible energy, and profound influence make it a true wonder of the universe. So the next time you feel the warmth of the sun on your skin, take a moment to marvel at the fact that this radiant star has been shining for billions of years, and it will continue to do so for billions more. It's not just a source of light, it's a source of awe.